Greetings students. In this lecture, we'll talk about limits. First off, we have one-sided limits. So there are basically two types of one-sided limits. We have the left-hand limit and the right-hand limit. In the left-hand limit, we have the number approaching from the left side of the number line, and in the right-hand limit, we have the number approaching from the right side of the number line. So if we just draw the number line here, we have 0 in the middle, 1, 2, and in the left side, -1, -2. So for left hand limit, we have the numbers approaching from the negative side, hence this a minus, while in the right hand limit, we have the number approaching from the positive side, hence this positive. So let us try to understand it with the help of an example. We have example that says f of x is equal to absolute x minus 4 over x minus 4, and we have x approaching to 4 from positive side and negative side, that is the right hand limit and the left hand limit. So for approaching from this positive side, we'll write x minus 4 as it is, and that would give us 1, while for the negative side, we'll write the negative part of absolute x minus 4, and that would give us -1. So we have 1 in the case of right hand limit and -1 in the case of left hand limit, and we can also deduce a result from it that left hand limit and right hand limit are not necessarily to be equal. In all cases, they might be equal, but it's not necessary that they must be equal. Now moving on to the next slide, we have the existence of limit of a function. Now, how are we to check that does a limit exist or not? The limit of a function exists if left hand limit is equal to right hand limit. The thing that we just talked about, that it's not necessary that the two limits must be equal, but they can be equal. And if they are equal, we say that the limit of a function exists. So let us check that whether the limit of this function exists or not. So we are to check the left hand limit, x approaches to 0 from the negative side, x over under root x, and we are to check the limit x approaches to 0 from the positive side, x approaches to absolute x, and if both of these are equal, we say that the limit exists, and if not, then the limit does not exist. So from the negative side, we know that we have to write the negative part, and for the positive side, we have to write the positive part. So cancels out, we have -1, and it cancels out, we have 1. So this means that the left hand limit is not equal to right hand limit, hence the limit does not exist. And why? Because left hand limit is not equal to right hand limit. In the case of left hand limit, we got -1. In the case of right hand limit, we got 1. Hence, they are not equal. Now moving on to the continuity of a function at a number. Now if we are to check that if a function is continuous at a given number, then how are we going to do it? A function f is said to be continuous at a number c if the following three conditions are satisfied. If f of c is defined, that the function is defined at that particular number, limit x approaches to c, f of s exists, that the limit exists when the x approaches to that specific number, and if the limit is equal to the value of the function at that specific number. If all the three conditions are satisfied, we say that the function is continuous at that specific number. So let us try to understand it with the help of an example. Again, we are to check that whether this function is continuous or not. So how we are going to do it? We know that if we are to check the continuity, we have to check the three conditions. That whether the value of the function exists at that number, first property. Second, that limit exists, and the third, the limit is equal to the value of a function. So checking the first property, we have to check that whether the function exists at x is equal to 0. So if we put x is equal to 0, we know that at 0, the function has a value and that is 1. So this means that the first property is satisfied. Now moving on to the next property, that the limit must exist. So we have to check that the left hand limit x approaches to 0 from the negative side, f of x, is equal to the limit x approaches to 0 from the positive side, f of x. If this is equal, then we say that the limit exists. So let's check it. So limit x approaches to 0 minus f of x would give us limit x approaches to 0, and from the negative side we are to use x, for the positive side we are to use x squared. So we write x and limit x approaches to 0 positive f of x is equal to limit x approaches to 0 x squared. By putting the limit we get 0 in this case and 0 in this case 2. So we say that the limit exists as the left hand limit is equal to the right hand limit. So the second property is satisfied too. Now we are to check that whether the third property is being satisfied or not, and that will decide our continuity. The third property says that the limit must be equal to the value of a function. Now we can see that the limit we are getting is 0 in both cases and we have the value of function as 1. So both of these are not equal. F of 0 is not equal to limit x approaches to 0 f of x. Hence, as the third property is not being satisfied, we say that the function is not continuous. So it's important that all the three conditions are fulfilled for the function to be continuous. I hope you got the concept, and that's all from us in today's lecture.